All right. Okay, so now let's get started. Okay. Oh, there are people in the waiting room. Thank you for letting me see that. Okay, I think I let everybody in. Sometimes switching screens around makes me lose that. Okay, so welcome to Metacognition to Improve Study Habits in STEM Learning. I'm assuming all of you are in a STEM class right now. I know several of you are from physics. Some of you have been in my classes before. Um, but regardless, even if you're not a STEM major, a lot of the stuff we're going to talk about today is translatable to any field, um, and actually even tasks that are not necessarily class related. So I think it actually is just such a wonderful topic, and I look forward to discussing it with you. First, I want to make sure to acknowledge the fact that ASU's foundation really has relied on the grounds where we have built our four campuses. And those grounds are historically the lands of 22 Native nations, and that includes the Akimel O'odham. I don't want to mispronounce that. I'm trying very hard. The Pima and the Pipash or Maricopa nations. I want to acknowledge that because it's very important that it is their allowance of our use of that land for ASU's campuses that enables us to be here today. So thank you to those nations. Thank you for anybody that comes from those nations. And thank you for everything. ASU is a really wonderful place to be, and it's really um, it's it's a lot because of those nations and their contributions. So thank you very much. Okay. All right. Yeah, of course. It's very important to include. Okay, so who am I? I am Anna Cunningham. You may have heard me. A lot of my students call me Dr. C. I kind of prefer that because not even my family calls me Anna. I won't necessarily mention what they call me, but I am pretty, well, I'll just tell you, they call me Bump because I'm extremely not coordinated and I bump into everything. So they don't call me Anna, they call me Bump. My husband calls me B or something. Or no, my dad calls me B, my husband calls me Boo. I don't, no one calls me Anna. My so and also so I just my students when I started teaching started me calling me Dr. C. So that's usually if you hear Dr. C, that's me. It's not because my name's hard to pronounce or anything like that. It's just it happened organically, but I love it. But my name is Anna Cunningham. I am a biology lecturer here in the School of Math and Natural Sciences. I am the coordinator for Bio 181 and work very closely with the coordinator for Bio 182, but I also am the lower division science coordinator. So interact with anybody in the School of Math and Natural Sciences that is involved in teaching 100 or 200 level science and math classes. So I also have a role in New College of Interdisciplinary Arts and Sciences, where I'm the co-director of Teaching Innovation and Excellence, which is kind of where this presentation is coming from. But also, my PhD is actually in microbiology. So I love, I I hate saying this kind of, but I love disease. Don't love a pandemic, don't love the pandemic, but I do love, I'm a bacteriologist by training, an immunologist, and really love how the body responds to disease. Cell biology is kind of my jam, which is why I focus on Bio 181. But if you have interests in those areas, here I am, please reach out. I am going to be on campus for the last week of classes this semester, but traditionally I am on campus and I am in the CLCC on the West Campus, and my office is 289. So please stop by. But you can always reach me. My email is just my name, anna.m.cunningham@asu.edu. And like I said, I love, I'm a very social person. I also love to help. So you have my contact information, use it. So why am I talking about studying today? I realize a lot of times I get, students who come in my class and they're like, oh, well, biology or physics or math or chemistry are all like really hard and I'm just not good at it. And so maybe it's not for me. And I really want to address this because I actually was not, I'm not a born scientist. A couple of reasons that metacognition is so important to me is because it actually really changed my life. I was a first generation college student. My parents, I think my dad took a couple classes, but they did not finish college. They are hairstylists, which I'm very proud of them. They're wonderful, but they didn't need a bachelor's degree to do that. With that said, I have nobody in my family who is a scientist, and so I'm first generation scientist. And actually, when I went to um, undergraduate, I actually went with pursuing art and English as a major. So, not even the sciences or anything like that. My background in science was not very strong. I went to extremely small schools in a very small Midwestern town and just didn't have a lot of exposure to those classes, unfortunately. And so I really entered college with like no background in science. I entered college not knowing what to expect. And so I was terrified all the time. I had no idea what to do or where to go or who to ask for help. But being a first generation college student and I had several scholarships and grants that were dependent on my GPA and my success. And so for that reason, I had a lot of pressure to succeed. So I was terrified all the time. I felt a lot of pressure and anxiety. And although I was pursuing art and English, I wasn't really 100% sure what I could do with that. Kind of entered college from the idea that like the only careers that existed were like being a doctor, which I didn't want to do, or being a lawyer, which I didn't want to do, or being a teacher, which I thought sounded pretty cool. I don't know how that is happening. But all of these things, which I kind of just I didn't know what I wanted to do. So, yeah. So, I don't know how to get rid of that. Sorry. I don't even know where that came from. That's okay. Let me see. Can I turn this off? Clear. Okay. There we go. All right. So, with that in mind, I kind of still like some steps that I took. I had a really strong community. I had a lot of friends. I joined all the clubs I could. I had some really good mentors. I used tutoring, which I'll talk a little bit about. I TA'd. I did research. I cried a lot in my room at 3 a.m. while I was studying specifically organic chemistry because I was so miserable at organic chemistry. But the really important thing that I did was I really tried to constantly assess myself and ask, you know, why am I here? Why am I doing this? So actually, I did not switch from art and English to science sort of like naturally. I actually was placed for some reason by work study as the prep for a molecular biology lab. I had never had science before. And I was horrified, but this was actually the person I was prepping the labs for. And he ended up being such a wonderful resource, but he was like, "You're really good at prepping the lab. Why don't you try, TAing for the class?" I was like, "I've never taken biology before." He was like, "Well, just give it a shot." And I actually fell in love with it, and that's why I switched. And I actually didn't switch until halfway through my sophomore year. And to tell you I was terrified would be very severely under emphasizing that my feelings. But here's the deal, and this is really important. I had in my journey, which I call it a success story because here I am, but I had in my journey a tremendous amount of community and mentors. I accessed tutors, I taught, I did research. Some of this happened organically, like I just happened to be placed in his lab for our class for TA ship. but some of it happened because I pursued these opportunities. So one thing, and this is not necessarily related to metacognition, but one thing that I wanted to say is use the resources that are available to you. And I'll talk about tutoring and we can talk about research, but take every opportunity you have to be involved. That is step one. That's how you establish your learning community. And that's what I really did. I'm a very social person. And so I really just sought every opportunity to do that. So I figured out I was going to pursue science. And so I got my bachelor's degree. I feel like it was pretty successful. I felt pretty proud of myself. I was like, okay, I'm a bachelor's in science. Yeah. Microbiology. And then I got into graduate school. And I realized I wanted to do graduate school because I didn't want to be a doctor. I didn't want to be whatever else, but I really wanted to pursue, specifically, I just wanted to know more about cell biology. And I figured more school couldn't really hurt me. So I just went for more school. I got into grad school and it was eye opening. It was eye opening. I actually failed my first class, had to repeat it. Super embarrassing. I'm going to share that with you. Because of that, obviously, I had a real good amount of imposter syndrome. I had a lot of self doubt, but I also was saying, why am I doing? I did great, and I was the outstanding biology graduate, and which is basically like the valedictorian for my bachelor's degree program in science. I did really good research. I, you know, I got good grades my bachelor's degree, and I was like, why is this different? Why am I struggling so much? Like, what is the difference? Um, it took a lot of introspection to try to figure it out. But what I realized, again, did the same thing I did when I started undergrad. I accessed tutoring. I established a community of friends who were in similar classes. And of course, you're engaged in research in graduate school. And I'll talk a little bit about the difference between some of the formative classes and some of the classes that you get in grad school or in your upper division classes in undergrad here in a minute, because that's where we're getting into metacognition. You may be like, why in the heck is she talking about all this stuff? Well, one, I want you to know that, like I said, science, getting the grades, all this stuff does not come easy. I'm a PhD in microbiology and I struggled. I worked my butt off to get here. Um, it doesn't come easy to everybody. Some people are better at memorization than others. Some people have more experience and therefore can contextualize things a little bit better. But that doesn't mean that they're more naturally gifted than anybody else. It's all hard work. So we'll talk about it. So I like to kind of summarize my grad school journey as grad school took 6 years. And here are my years in grad school. My first year, all my experiments failed. So I went to my mentor and I was like, what the heck do I do next? My second year, I had a couple of successes. I have like 2 or 3 papers, but a lot of failure, a lot of experiments don't turn out, right? And I would go to my mentor. My third year, man, none of my experiments were working. I went to my mentor. My fourth year, all my experiments were just, I was getting negative data. It's not like the experiments were not working. It's just like, it wasn't really exciting data. I was working on vaccines for Lyme disease. They were just not really working. And then my fourth year, what started to happen is my experiments wouldn't work, but I would sort of think of like, why aren't they working? And then I would ask my mentor to like follow through. And then what started happening in my fifth year is my experiments would work. And so I would think, why aren't they working? I would come up with a plan, like what's next? Then I would follow through. I would do everything. I would think of it, I would follow through and I would do it. And then instead of consulting my mentor, I would just say, hey, I did this, just so you know. And one day when I was like, I'd done all this stuff, I found out my experiment did not work. Lots of negative data. What I thought was exciting data was actually just like a false positive. I was really bummed, but I had done it all myself. I had thought about it. I had come up with this. And then I just kind of was updating my mentor. And he was like, You're ready for your PhD. You're ready to graduate. And I was like, what? My experiment failed. But he was like, it's not about how many experiments you get that succeed, because that's really not science. That's not practical science. It's about how you think. So you'll notice that anybody that gets a PhD doesn't mean like you're an expert in microbiology. I mean, theoretically, that is my field. PhD literally means doctorate in philosophy. And philosophy is thought. And what you're doing when you're working toward that, you'll notice those higher degrees, master's degree is mastery of a subject. PhD is mastery of thought in an area. So I thought up until this point, I was like, man, I'm working really hard on like being a master of microbiology, but I wasn't really working that hard on being a master of thought. And it wasn't until I got that PhD that I was like, oh my gosh, I do think my thought processes are so different than they were in my bachelor's degree program and throughout my PhD program. And when I came out of that PhD, I was like, I can think. But the big thing here is that is metacognition. You don't have to have a PhD to understand metacognition, but it has really been an underexplored field until recently. But metacognition is really something that PhDs are trained to do, but they're trained to do in their field of specialty. So we're going to make you a PhD of studying. That's my goal here today. So what in the heck is metacognition? So here I have a picture of one of my very favorite scientists, and she is a revolutionary in the field of metacognition. Her name is Dr. Sandra McGuire. I was very fortunate last year to be able to see her speak in person. And she is one of the most inspirational people I've ever met. I'm going to recommend a book to you that she's written. She's written several books on metacognition. She is an expert in the field. But I also have some really cool slides. If you're interested, I can send those on. But what is metacognition? Metacognition is the process of thinking about thinking. So what the heck does that mean? Whenever you're thinking about thinking, it's really actually thinking about the thought processes that are involved to like plan, monitor, and assess understanding of a concept, right? So it's sort of saying, how can I learn this? What is involved in learning this? How well do I know this? Where are my deficits in this? And that is really important, right? So in college, you're presented with a lot of facts, right? But it's not just like, I have to memorize these facts, because on your tests, you're not usually having to like regurgitate those vocab words or anything like that. You're having to understand how they are incorporated into, are contextualized into the bigger picture. So that's what you're trying to do. Metacognition is trying to figure out, how can I contextualize this information to truly not memorize it, but learn it. So we'll talk about it. So first off, okay, so I want you to, what the heck am I talking about? So first off, it is really, really important to acknowledge that the process of learning is actually really, really hard. Your brain doesn't like learning. I know that's really funny to say, but your brain is very lazy. It doesn't like to learn. So what I want you to do is cross your arms, just without thinking, cross your arms. Okay, now try to cross them the other way really fast. Okay. Unless you're ambidextrous and do that all the time, that was awkward. Okay, it's awkward. If you cross your arms without thinking, that's how your brain is used to crossing your arms. It's like a natural position. But if you're like, okay, I have to switch my arms. I mean, I can't even figure out where my hands go. Like I cannot cross my arms the other way. And that's because that's something new, right? Your brain is used to doing it one way and you're trying to make it do it a different way. Your brain is like, no, it works this way. This is the way I'm going to do it. And that is how your brain, unfortunately, approaches every new thing that you will encounter. Your brain basically says, I like what I'm used to. I don't like anything new. New stuff is hard. I expend enough energy just like keeping this body alive. Why do I want to expend energy learning new stuff? And part of that is practical, right? Like I said, it takes energy to learn and you want to conserve energy. So it makes sense. But here's the deal. If you're studying by like you take notes, let's say that you're in class, you're listening, but you're taking notes word for word. And then you go home and your studying method is to read those notes over and over and over again. When you do that, you become familiar with the words that are on that page. You're becoming familiar and you're learning to recognize the words that are on that page. But even though you can read and you can like those words are making sentences, and those sentences are making paragraphs, and those paragraphs make sense, at the end of the day, when you're reading notes, the only thing that your brain is really retaining is familiarity with the words that are on that page. So the problem here, and I get this all the time when students read notes and they're like, I remember reading this, but then you get to a test and I don't know how many of this, it happened to me all the time. How many of you take a test and you're like, I worked so hard. I studied for like 3 hours. I read through my notes like for 3 hours, but I got to the test and it just wasn't there, right? That's because tests require you to recollect information, to draw it from memory. But how you studied, you became familiar with the material by reading through, recognizing it. So your brain is used to recognizing those words. It can recognize a definition or it can recognize, an equation if, all of it is laid out in front of it. But if you have to recollect it, your brain hasn't been trained to process it that way. So we'll talk about that. Okay. So we're going to talk about how to trick your brain into focusing on the new. So first off, before I do that, what I want to ask, and I'm going to do a poll here, is when you think of 2 tasks. So if you were given 2 tasks, one of them was to make an A on the exam, and the other one was to, like, let's say you have a concept and you can either make an A on the exam covering that concept, and the other task is to teach that material to the class. So for example, if I said you can either take an exam on this concept and you have to get an A, or you can teach the material to this class, right? For which of these tasks would you work harder? So I'm going to launch this poll. Hopefully you can see it. If you see the poll pop up. Okay. Right. I see about 20 of you have responded. I'll give you a little more time for those who haven't responded yet. Right. Okay. Okay, pretty good. All right. Okay, I'm going to call it. So hopefully everybody can see the results. So it looks like about 70% said that you would work harder for teaching the material to the class as opposed to making an A on the exam. So 70% of you would work harder to teach the material to the class. So I'm going to stop sharing for a minute. Would anybody be willing to share, like, why would you choose?
I chose an A on the test, because when you're teaching material, you have notes in front of you and you have textbooks, and you can read it, and if you understand it, you can answer questions with it. But it doesn't mean that I actually have retained all of that. Teachers have all those resources right in front of them.
So what if
And
I told you that you couldn't have notes or your textbook or anything in front of you? Because when I teach, I don't have all that stuff in front of me. I wish I did.
Oh, well, all of my professors always have stuff in front of them. Then I would pick
Each their own. That's fine.
Can I change my answer?
No, that's fine. I think your answer is good. That's fine. What? I see two hands raised. Either one of you?
So in my psychology class, I was actually just studying learning behaviors.
Yeah.
And the brain, what I remember from it is that the brain tries harder to reteach this information, and then it helps you retain that information, as opposed to just studying for a test, which doesn't work for me. So I talked to my fiance about the goals and the sections in each chapter that I'm doing, and that's what helps me learn better.
Excellent. Awesome. Thank you both for sharing. Those are both good responses. I think I saw, was it Desiree?
Yes, I had raised my hand.
Yeah.
Similar as what was just said before, I put teaching it because I just know in my experience that's what helps me actually retain it rather than just memorize it and then throw it out later. Even I have little sisters and I will teach them college level stuff to help me understand it because they're the only ones that'll listen. But yeah, that's why I chose that.
That's excellent. So actually, that's such good comments. And Christina, I want to mention, so everything that you all said is so true. And actually, every time we take that poll, if you think about the anxiety that it takes to study for an exam, a lot of anxiety, versus having, and Christina, the key word here is you have to know it well enough to teach it. The anxiety of knowing something well enough to be confident to stand in front of a class and teach it. Honestly, you're going to want to know it before you, before you teach it. And so the thing about it, and this was mentioned by both of the other two people, and I would say, and I know Chris, you said that your name is not Chris, but now I want to make sure I get your name right.
So my name is Olivia.
Olivia.
I think when I opened Zoom, my fiance's name was still logged in for his stuff, and I can't figure out how to fix it. Okay. So you can definitely call me Chris today, and I will just put that in the chat too when we give you our emails that I'm Chris Owers, but my email is Olivia Kotecki. So.
Oh, okay. I'll call you Olivia.
Okay, I'll answer to Chris too. That's what it says on the thing.
But so Christina, you said you have to really understand it. And Olivia and Desiree, you said the same thing. Yes, in order to teach something, you really have to know it. But when you're studying for a test, it's not so much like you need to explain it conceptually, but you need to be able to recall information. So people will work much harder to be able to teach it. So I have another question for you. And that's a really important part of learning. You learn better if you think you're going to have to explain it conceptually. And I love the tasks you said. So Olivia, you said you explain it to your fiance, and Desiree, you said you explain it to your little sisters. Excellent. Teaching is one of the best ways to test and see if you really know it. One thing I'm going to promote the tutoring center a lot. One benefit of tutors, although there's many, a huge benefit of tutors is that you can explain a concept to them and they can fact check you, which is really important. Because I used to teach things to my cat and my cat can't correct me. So that was not as helpful. But the really important thing, so teaching it is huge. Teaching it to somebody that can correct you. There we go. All right, so I'm going to share my screen again. And I actually think that I have another poll question for you. So here is the question, and I'll launch the poll in a second. When it comes to learning, when you think about learning, what do you think is the most important driver of learning something? Is it somebody's intention or desire to learn? Is it paying close attention to the material as you learn? Is it your learning style? Is it the time you spend studying? Or is it what you think about when you're studying? So I'm gonna I'm gonna go back to my polls. Let's see if I can. Oh, here we go. What just happened? Sorry. Hopefully you can still see my PowerPoint. Okay, I launched that question, so please answer. When you think about studying, which of the following is the most important to learn? Is it your desire to learn it, your intention to do so, paying close attention to material, learning style, time spent, or what you're actually thinking about when you're studying? Okay. All right, we're getting some good responses. Thank you. All right, just wait a second more. Okay. Okay, so I'm going to end it. Thank you for everybody who responded. All right, so it looks like the vast majority of you said that the most important thing would be your intention or desire to learn, and coming in a close second would be what you think about when you're studying. Okay, so when it comes to learning stuff, I think this is really important. I'm actually really excited about your answers. When it comes to learning, what we know is that intention is important, right? So like wanting to learn something is important, but it can actually only take you so far, right? I want to learn how to fix my car, but it's not going to get me there fully. Paying close attention to material as you learn, that is important and it can help, but it's not necessarily being active and engaged in the material, which, as we'll talk about, is really important. I'm so glad that the vast majority of responses, it used to be that the vast majority of responses would be like learning style, but now we know more and more that although learning styles are a little bit of a myth, although we tend to say like, I learn better in this way, I learn better in this way. In all reality, true learning needs to be kind of multifaceted. And really, when it comes down to it, learning needs to be active. So active learning can be visual, audio, kinesthetic, it can be any of those, but it just has to be an active process. And we'll talk about that. So learning style doesn't really impact. So a lot of people are like, I can't do math because I'm more of a visual learner and I need, this sort of thing. But that's a misconception, right? It just has to be active. It can be visual. Time spent studying, you do have to put a lot of time into it, but some people can do active studying a lot more quickly than other people, and that's okay. But, I can't tell you as an instructor how many times students come to me after an exam and say, man, I worked so hard on this exam. I studied for 4 hours last night. And I'm like, well, that's not enough. That's not enough. It's not about the time, right? As we'll talk about. It's not about the quantity, it's about the quality. So when it comes down to it, the really important thing about learning is what you are thinking about when you're studying. Because although, again, all of these can contribute to memorization of facts, you're not truly going to learn it in a usable way unless you're contextualizing that information. So let's talk about this. So metacognition is a really wonderful cycle, and I can give you a bunch of resources about where it was incepted and development, but essentially it's saying that to truly learn something, it takes a cycle, right? So first you have to look at the task. What are you trying to learn, right? What is it I'm trying to learn? Because you can't learn everything the same way, right? So like I mentioned, I went from undergrad where I learned, I could, sort of memorize. I can memorize things. I have a very good memory. And that served me very well, right? Until I needed to apply something. I will say that my undergraduate experience was probably very different from yours because ASU is very good in their classes about adding context and application style questions. I went to undergrad that was a little bit more kind of like old school, where it was a lot of memorization. And so I did pretty well memorizing. But when I went to grad school and I had to apply it, I mean, I could not study the same. And it really was hard. You cannot study the same for every class. You're going to study different for math than you do for like biology or chemistry. And so what you need to do with metacognition is you need to see, what exactly am I focusing on? What is my task? And then a really important thing and the really cool thing about metacognition, at least why I think it's cool, is it involves a lot of self-evaluation. So we'll talk about this here in a minute, but it's really, really important to, when you look at a subject, ask yourself, what do I know about this subject? But equally important is to ask yourself, what don't I know about this subject? I'm a microbiologist, but I can tell you 100%. I don't know everything there is to know about microbiology. And it's really important to find my deficits because I can't correct those deficits unless I know what they are. So it's really important to evaluate, what do you know? What don't you know? Right. So once you kind of have that in mind, like, what is this task? Where do I need to work? And then you need to ask, how am I going to do this? So we'll talk about some strategies there. And then you can apply the strategies and we'll talk about those. But a really, really important thing after that is to say, how well did these work? Could I have done something differently? So let's talk about it. And then you can do it all over and over and over and over again, which is so fun. That's why it's a cycle. So when it comes to assessing the task, a couple of things to ask yourself or, how do I plan on preparing for this upcoming assignment or exam, etc. So how am I going to approach this? It will be different if it's an assignment versus an exam, right? Exams do require a little bit more recollection, whereas assignments typically involve some sort of, contextualization or creation. So different tasks will require, different modes of preparation. Always ask, what resources are available to you to support you? Can you talk to colleagues about this? Can you talk to the tutoring center about this? If it's a writing assignment, we have a really wonderful writing center to give you feedback on that. You need the point though, if you're saying, and what I'll say about metacognition is the point isn't always necessarily to get an A. The point is to learn it. But if you learn it, the A will follow. And so with that, it doesn't have to be, it's a writing assignment. It shouldn't be, I just need to get it done. And it needs to be good enough to get an A. It should be, I need to learn through doing. All of your assignments will always be, as instructors, we give you assignments. The assignments are formative. Exams are typically assessments. How much do they know? Where do we need to, kind of focus more? But assignments are all formative. So when we give you a writing assignment, it's so you can learn to write. So use your resources. What else is available to you to help you learn that? Always ask others how they're preparing. I ask everybody. I'm like, how do you do this? I love it. Collaboration is my favorite thing. What concepts do you fully understand? What do you not understand? And where are you focusing your studying? So remember when I said your brain is lazy? It's not an insult. It's like my brain is lazy too. Remember that your brain will focus on what it likes. So I'm a biologist, so that's my frame of reference. But if I give you two facts, so one is mitochondria is the powerhouse of the cell. And the other fact is Krista are the membrane compartments in mitochondria where concentration gradients are generated, and it is the concentration gradient established across that membrane that gives the energy for ATP production. Which one of those does your brain like better? I'll tell you which one my brain likes better. My brain likes mitochondria as powerhouse of cell because I'm told that repeatedly my entire life, all the time. So if you tell me the other thing about membrane potential in the crista of mitochondria, I'm just like, and my brain is just like, no. Your brain doesn't want to learn that. It's way easier to just know the mitochondria as powerhouse of cell. So one thing your brain does is if you're presented with a lot of new information, it will preferentially focus on the stuff you already know. So this is really important when you're focusing your studying. If you know something, take it out of your notes. Don't write it down. Don't make a flashcard about it. If you know, you need to be selective with the information you're showing your brain. You have to show your brain the stuff that you want it to focus on. And that has to be the new information. Okay. A couple of mistakes you can make when assessing yourself. One is overconfidence. And I don't want to tell you just always be hard on yourself. Don't always be hard on yourself. I think you are all incredible. The fact that you are here speaks volumes about who you are as people and students. Not that, tons of people couldn't make it, so it doesn't mean they're bad, but you are here because you want to improve. So you're wonderful people. But a huge mistake that a lot of people make when it comes to learning is overconfidence. I did great in high school biology, so this is going to be pretty easy. I know the mitochondria is the powerhouse of the cell, so I know everything there is to know about organelles, right? That's an oversimplification. But one thing that people miss when it comes to learning, and this is one of the most common things, is overconfidence, saying, I don't need to focus on this as much because I feel pretty confident about it. It is extremely important for every concept you learn to assess what do you know? What do you not know? Right? Assess both of those. It's always kind of recommended to kind of say, to kind of default to, I don't know about as much about this as I think I do. And then cramming, right? So we'll talk about this, but one thing your brain needs to do in order to remember something is it needs to contextualize facts. Your brain, again, is pretty lazy. So if you're just giving it terms, those terms are pretty much meaningless. So for me, when I think of understanding membrane potential in mitochondria, my brain is sort of oh. But if I'm the membrane is sort of like the Hoover Dam, and membrane potential is sort of like the water stored behind the Hoover Dam. That's a ton of potential energy. If I was to make a crack in the Hoover Dam and water comes flying out, that's a ton of energy. That's ATP. Oh my gosh. That makes sense. My brain work, and this is true for brains in general. Things make more sense if you give them real life or contextualization that makes sense to you. And so for me, I went to the Hoover Dam once. And so I'm like, oh, the Hoover Dam makes sense. But if there's something else that makes sense to you, use that. But the thing is, you cannot make those connections overnight. Your brain making those connections and those contextualizations and all of that takes a long time. And so you have to give it time. And so cramming the night before a test, you might memorize some terms. But truly understanding and true learning, it's not enough time. Memorizing isolated facts, again, contextualization is the most important thing here. So remembering terms, you can remember membrane potential is, it is what it is. But it's kind of meaningless. And again, the majority of college classes are going to ask you to apply that knowledge. And if you haven't practiced that application and that contextualization in your brain, then it's going to be really hard to be able to do it on an exam. I already talked about this, but no one is just good or bad at a subject. They may had more experience. They may have more support. They have maybe contextualized a concept before, whatever. But everybody has the potential to learn this information as long, if they put the work into it. And also multitasking is a myth. No one is actually good at multitasking. You know who's really bad at multitasking? Your brain is terrible at multitasking. It's pretty good if you're I need to wash the dishes and I need to feed my child and I need to whatever. It's pretty good at those. But when it comes to complex tasks, you can't learn something while multitasking. It takes focus. Okay. So when you're planning your strategy for metacognitive-based studying, you need to do two things. You need to establish long-term goals, and those goals don't have to be like super long-term, like getting an A in this class is not really a realistic long-term goal. It needs to be long-term goals sort of are short-term still. But like, let's say your first exam is your long-term goal. You need to set short-term goals that will lead you up to that. So for example, make these daily tasks every day, pick 2 concepts from every class, and you're just going to review your notes about those, maybe make a concept map, do some practice problems. And importantly, like we talked about earlier, try to explain it to somebody. Maybe try to explain it to somebody who has never heard of it before. That will be helpful. Teach it to them. Maybe try to explain it to an expert, because then they can call you out. So I'm going to talk about this. When it comes to studying, like I mentioned, there are 2 types of studying. You can do passive studying, in which case you're training your brain to recognize, which will not be helpful on an exam, because on exams, you have to recollect information. You want to be doing active studying, because this trains your brain to recollect, to apply, and to conceptualize. And this involves how your brain processes information, actually. So there is, with that, what we call shallow processing. That's where you're just kind of like memorizing definitions or isolated facts, or maybe just rewriting your notes. So it's sort of like, I don't know how many of you in here have like read a book, you read a passage in a book, and then you're just sitting here and you're like, I have no idea what I just read. Happens to me all the time. I'll be reading and I have to reread the same paragraph like 4 times because I have no idea what I read. So that's shallow processing. Deep processing is where you engage your brain. So again, this cannot be done while multitasking, and it involves assigning kind of like meaning to a concept. How is this? Why does this matter? How does this apply? Relating any information to prior knowledge, again, contextualizing it in the scheme of what you already know, how, importantly, how this information is personally meaningful, right? So something I like to say is when you're learning about cellular respiration, or you're learning about some sort of, process, how does this apply to the system? Why does this matter? When I was learning about cellular respiration when I was an undergrad, it was so hard for me. I hated it. It made no sense. I was like, why do I need to know this? It wasn't until years later when I understood the system, the human body, and how it works, that I really understood that cellular respiration generates like ATP and all the processes that require ATP and how energy efficient it is and all this stuff. I couldn't contextualize it until years later. So that contextualization, assigning that importance to that concept, is vital for you remembering it, because your brain's going to forget anything it doesn't care about. It takes too much energy to memorize it. You have to make it important. So these are just some strategies that are more passive or active. Like I said, I will send this out to anybody who attended afterward, because I want to make sure I have a little bit more time to kind of move through the remaining. But when you're talking about passive study habits, reading the text before class, reading, any assigned text, highlighting the text, coming to class, taking notes word for word, those are really not engaging your brain at all. Active study habits are really where you're going to start engaging with the material and engaging your brain in learning. Summarizing your notes in your own words is really beneficial. Writing your own study questions. So I always say this. So like as an instructor, I have to look at the material, and then based on that material, I have to write exam questions. It doesn't take me any special brain power to like write exam questions. Technically, anybody can write exam questions. you can write exam questions. And actually, that's a really, really wonderful way to learn the material. And I think it's a really wonderful way to study too. Because if you take a concept, there's only so many questions that you could ask about it. So if you're trying to look at a concept and saying, what kind of questions could you ask about this? You're probably going to come up with a lot of the same questions that are going to be on an exam, because I'm not any more creative than you. Your instructors are trying to come up with exam questions, and there's only so many we can come up with. You have the same power to come up with an exam question. Close your notes, right? And then test how much you remember, right? Try to recite it. Speak out loud or tell it to somebody, teach it to somebody. Always ask yourself, how does this work? Why does it work this way? Why does it matter? And try to fit it into the bigger picture. It is so easy in these classes to get lost in the details, right? Like I said, okay, cytochrome is helping move hydrogen, pump electrons to move hydrogens to one side of a membrane. It's establishing a concentration gradient that's fueling ATP synthase, it's generating ADPT. Okay, why do I care? But you have to. Your brain is not going to care unless you make it matter. So that's really important to contextualize it, right? So again, I will send this out and we're getting close to time, but I promise I will make sure. But if you have to leave, go ahead and just type your name and your email address into the chat so that I have your name and email to send this to you afterward. But if you can hang out for a little while longer, that's great. But we have about 5 more minutes. So if you can hang out, that's great. If you have to go to class, I totally get it. So it is really important that metacognition is a scientific field. So for every new topic, you need to approach it like a scientist. Metacognition involves asking about these concepts, asking, how does this work? How does this fit into the bigger system? Why is this important to know? What kind of problems would require this knowledge? Those are all things that contextualize this information for you. And that is really, again, like the most vital thing to do. So I don't want to rush through this, but I want to make sure to get to a couple of things. Very importantly, self-reflection matters. So for every subject you learn or every method you used, what method worked well? Did going to the tutoring center and talking to somebody about this help me? Did using the writing center help me? Did taking notes passively help me? What didn't work well? What did work well? Why? And then how are you going to improve? Should always be asking how to improve. So we went through the cycle, and I just want to kind of show you this slide I created to kind of give you an idea of what your workflow, if you want to design your studying based on the metacognition style, this is sort of what your workflow would look like. Assess your task. What is the assignment? Figure out, what do you already know about that subject? What do you not know about that subject? Plan your approach, both short-term, daily, and long-term goals, maybe exam or something like that, a big assignment, big report, whatever. Apply active learning strategies. And then after you've completed that, reflect on how you approach the assignment, how successful you were, and revise as necessary. I want to mention a couple of things too. When it comes to metacognition, little and big things matter. So each assignment, like I said, as instructors, we come up with assignments to help you kind of like learn a concept. But so each one of those assignments should be seen as valuable, each little thing, even if it's like a daily reading assignment. We have created that for a reason. However, none of this matters if you don't always have a why in your mind. Why does it matter for you to learn this? Why does it matter for me to learn cellular respiration? Because I want to be a microbiologist and I want to understand the disease process. And that matters so much. Why do I need to know this? Even like the little things. I know I keep using cellular respiration just because I hated it so much. But for me, that was like a big point. But that's the thing. If you remember your why, fit those little things into your why, right? So make those assignments relevant to your life. Some important takeaways when you're studying, make sure to eliminate distractions if possible. If you're going to listen to music, that's fine. Just make sure it's familiar music and that, having words doesn't always help. Failure is not a bad thing. Many assignments are given. Failure is not necessarily a bad thing. It is an opportunity for feedback. Like I told you, I failed my first class in graduate school. I'm still a very successful scientist and lecturer and everything. I took that as an opportunity to assess myself and learn. Failure is not bad. It's an opportunity for feedback. Use your resources. I'll talk about the tutoring center, and realize that everybody has an opportunity to get an A. I want to mention that there is an upcoming seminar, speaking of having what we call a growth mindset. Dr. Karen Sipola will be giving a talk on stretching for success, which is kind of having that mindset and how that can also help you improve in STEM. And we'll be sending out reminders about that soon. Some resources for you if you want to learn more about metacognition. Again, Dr. Sandra McGuire is like my huge inspiration to me. You can get this book on Amazon for like $15. If you are interested in this book, but you are undergoing financial hardship, send me an email. I will help you. Just let me know. I would be more than happy to help you obtain this book. This website is free. It's a series of wonderful videos kind of talking about how to best study. And this book also is the book that I read when I was in graduate school that basically changed my life and helped me be successful in graduate school. And that's also about metacognitive study habits. I want to advertise university academic success programs. That's where you go for tutoring. You should try to teach the tutors what you know. And then finally, I, of course, am here for questions. This is how you can contact me. Even though I'm maybe not teaching you in a class this semester, I would be more than happy to talk to you during office hours, just kind of discuss anything you want to know. I'm here. Again, Anna Cunningham, and I got an iPad for Christmas and I really like drawing. And then these are some resources I used for this. Again, I'd be totally happy to share with you that after. Okay, I'm so sorry that I feel like I had to buzz through those slides at the end. I hope that they were still beneficial, but that is my presentation today. Hopefully everybody typed their name and their email address into the chat. For everybody that did so, I will send a copy of the presentation, the slides, the recording. If you're interested, like if you're undergoing financial hardship, but you're interested in that book by Dr. McGuire, let me know. I'd be happy to help there. And then if you have any questions, I'm totally happy to hang out longer. I'm going to stop recording for questions